Hello everyone. Welcome back to SHR Trinity. So far, we have looked at how one-shot prompting enforces formats and personas. Today, we step into advanced territory, complex logic and edge cases. In this video, we will learn how to use a single example to teach the model how to gracefully handle missing data, ambiguous inputs, and logical fallacies. Before we start, if you're looking for practical, industry-oriented training in artificial intelligence and generative AI, SHR Trinity offers a comprehensive 30-hour training program. For complete course details, check the description below. Now let's begin today's interview session. We will now continue our series with 10 questions focused entirely on complex logic and edge case handling. Moving on to our next question. How do you use one-shot prompting to prevent the model from hallucinating data when a user's input is missing required information?
Welcome back. Today, let's talk about handling missing data in LLMs without triggering hallucinations. You see, language models are probabilistic text completers. When you ask for structured data, say, a user's name and age, and the input text only mentions a name, the model's natural impulse is to invent an age just to complete the pattern. To stop this, we use one-shot prompting specifically designed around edge cases. By giving the model a single concrete demonstration where required input is missing, we set a clear pattern for how to behave. Notice our bullet points. We emphasize that LLMs fill in blanks by default, so we must teach them safe failure states using placeholders like null or not applicable. A frequent mistake developers make is providing pristine, perfect example inputs. When real-world messy data hits production, the model panics and hallucinates. Now, look at our real-time example. The input provided is simply, "My name is John." Notice that age is completely absent. Instead of letting the model guess age, 30, our example explicitly outputs a JSON object with name set to John and age set to null. When the LLM sees this standard during inference, it copies the exact logic, recognize missing data, apply the designated fallback value, and move on safely without hallucinating.
Moving on to our next question. If your application requires the LLM to perform mathematical calculations, why is a one-shot example critical?
Hello everyone. Today we are addressing a core limitation of LLMs, basic math. It is crucial to remember that LLMs do not have built-in arithmetic logic units. They are pattern matching engine predicting the next token. If you ask an LLM to calculate a complex math problem and request only the final number, it will try to guess that number in a single forward pass, which usually leads to errors. This is why a one-shot example is essential. As listed in our summary points, a properly structured example acts as a computational scratchpad. By writing out intermediate calculation steps token by token, we give the model compute time during generation to work through the logic before reaching the final answer. This bridges one-shot prompting with chain-of-thought reasoning. If you skip these steps in your example, the model will copy your shortcut and guess incorrectly. Let's walk through our example step by step. Suppose we need to compute total cost with tax on a $100 item. Instead of showing an example that jumps directly from $100 to $105, our one-shot example explicitly demonstrates, Step 1, calculate tax, 100 by 0.05 equals 5. Step 2, add to base, 100 plus 5 equals 105. Final answer, $105. When the model processes a new calculation, it follows this exact sequence, computing intermediate values sequentially and dramatically increasing accuracy.
Moving on to our next question. When designing an AI router that categorizes user intent, how can one-shot prompting handle ambiguous queries?
Class, let's look at how to build reliable AI intent routers. In production architectures, an intent router takes incoming user messages and classifies them into actionable routes like cancel_order or update_billing. However, real users routinely send vague or incomplete messages like "Hey" or "I need help." Without guidance, an LLM router will forcefully guess one of your strict categories, routing a generic message to an incorrect department. To fix this, we use one-shot prompting to set explicit classification boundaries. As outlined in our bullet points, showing one example of handling non-actionable input establishes a clear threshold for routing. If you only provide examples of perfect queries, the model assumes every input must map to a primary category. By introducing a designated fallback category like clarification_needed, we give the model a safe destination for low-confidence inputs. Walk through our example with me. The input is simply "I need help." This input lacks any context regarding billing, tech support, or account management. Our one-shot example maps this specific input to category, clarification_needed. When the AI router encounters similar ambiguous user prompts, it matches the pattern and safely routes the request to a clarification workflow rather than incorrectly triggering an automated downstream system.
Moving on to our next question. Can you use one-shot prompting to teach a model a completely fabricated logic rule that doesn't exist in the real world?
Hello students. A fascinating property of large language models is their ability to temporarily unlearn real-world facts inside a prompt context. We call this an in-context learning override. Suppose your company operates under proprietary database rules where, hypothetically, certain fruits are categorized as vegetables. If you use zero-shot instructions like treat fruits as vegetables, the model's massive pre-training data will fight you, and real-world facts will routinely leak through. As our key points highlight, zero-shot directives are rarely strong enough to overwrite deep factual weights. A single one-shot example, however, acts as a concrete demonstration of your custom universe's rules. Demonstrating the rule in action forces the model to prioritize the in-context pattern over its pre-trained knowledge. Let's analyze the step-by-step example. We give the model an input, classify apple, and the example output strictly reads, vegetable. Now, when we present the actual evaluation task, classify banana, the model observes the structural logic from the one-shot example. It suppresses its pre-trained knowledge that a banana is a fruit and correctly follows our fabricated business logic, returning vegetable. This proves how effective examples are for enforcing non-standard business rules.
Moving on to our next question, how do you handle conditional output formatting, e.g., returning JSON on success, but plain text on error, using one-shot prompting?
Welcome back, everyone. Today we are examining an important architectural limit: when should you abandon one-shot prompting? A classic test in AI system design is asking a model to return JSON when an operation succeeds, but switch to plain text when an error occurs. Candidates often try to solve this with a single one-shot example, but it almost always fails in production. Why? As highlighted in our summary points, a single example can only demonstrate one structural format. If your one-shot example shows a JSON response, the model will attempt to force error messages into that JSON structure. If your example shows plain text, it won't understand how to format the valid JSON schema. Trying to jam conditional if-else logic into a single example confuses the model. Look at the example case. You want valid input equals XML and invalid input equals plain text. If you only provide one example showing the XML path, the model has zero structural references for the plain text error path. The lesson here is clear: conditional formatting requires at least two examples, one for success, one for failure. Knowing when to upgrade from one-shot to few-shot prompting is a hallmark of an expert prompt engineer.
Moving on to our next question, if your AI is extracting names from a text, how do you prevent it from extracting pronouns, like he or she, using a one-shot example?
Hello class. Let's talk about negative constraints. One of the most common pitfalls in prompt engineering is telling a model what not to do, such as extract all names, but do not extract pronouns like he or she. LLMs notoriously struggle with negative instructions because the words he and she are now present in its attention window, making them more likely to be processed. Instead of negative constraints, we use positive pattern filtering via one-shot prompting. As summarized in our key points, the golden rule is, your example input must contain the noise you want the model to ignore. If your example input only contains proper names, the model learns nothing about handling pronouns when they appear in real data. Let's walk through our example step by step. The input text reads, John went to the store. He bought an apple. Notice that this input contains both a proper noun, John, and a pronoun, he. In our example output, we strictly provide, names found, John. By observing that he was present in the input but completely absent from the output list, the model instantly learns the positive selection rule and successfully ignores pronouns in future prompts.
Moving on to our next question, how do you ensure the LLM cites its sources from the provided context using one-shot prompting?
Welcome everyone. Today we are covering source attribution in retrieval augmented generation, or RAG systems. When building enterprise search engines, it's not enough for the model to give a correct answer, it must prove where that answer came from by citing its source context. Telling an LLM cite your sources in plain text instructions often leads to inconsistent formatting or missing citations altogether. To enforce strict auditability, we use a one-shot citation template. As noted in our bullet points, LLMs are exceptional pattern replicators. If you show the model a factual claim immediately followed by an inline bracketed citation, it will adopt that precise syntax across its entire response. Conversely, if your prompt example lacks citations, the model will follow suit and drop citations from its final response. Let's walk through the example to see this in practice. The target output demonstrates, the company revenue grew by 20%, Doc 2, driven by software sales, Doc 1. Notice how every independent claim is tied step by step to a specific document ID. When the LLM processes new retrieved documents, it mimics this exact mapping layout, linking synthesized claims directly to document tags and ensuring complete grounding.
Moving on to our next question, what is example bias, and how does it manifest in complex logic tasks?
Hello class. Today we are discussing a subtle but dangerous failure mode in prompt engineering known as example bias. Example bias happens when an LLM observes an example and mistakenly assumes that coincidental details in that example are mandatory rules it must follow for all subsequent tasks. Let's break down the bullet points. LLMs are hypersensitive to context correlation. If your single example for a customer support router uses a ticket about billing mapped to high priority, the model might infer that all billing issues are high priority, even if your instructions say priority depends on urgency. The model overfits to the domain of the example rather than learning the abstract logical rule. Look at our real-world example step by step. Suppose your one-shot prompt features a story where the doctor character is referred to as he. In subsequent generation tasks, when asked to generate details about a new doctor, the model might consistently generate male doctors, carrying over the gender from the example as an absolute constraint. To prevent example bias, you must design semantically neutral examples or upgrade to few-shot prompting with diverse examples to decouple the underlying logic from specific domain details.
Moving on to our next question, how can one-shot prompting be used to enforce chain of verification?
Welcome back. Today we are exploring chain of verification, a powerful technique that forces an LLM to double-check its own logic before providing a final answer. Left to themselves, models output responses linearly without re-evaluating earlier tokens. If a model makes an early logical error, it continues down that flawed path. By using one-shot prompting, we can enforce a multi-stage self-reflection template. As outlined in our bullet points, generating intermediate verification tokens gives the model the necessary compute space to evaluate its initial thought. By showing an example that explicitly writes out a draft, checks that draft against facts, and then produces a final answer, we train the model to execute self-correction in real time. Let's walk through the example step by step. The output structure demonstrated in our one-shot prompt is, draft, the capital of France is Paris. Verification, is Paris located in France? Yes. Final answer, Paris. Notice the three distinct phases, first drafting, then asking a verification question to validate the draft, and finally outputting the verified answer. When the model receives a complex query, it follows this exact multi-step pattern, catching its own mistakes during the verification step.
Moving on to our next question, if a one-shot prompt is failing on complex logic, What is the absolute best way to debug it?
Hello everyone. To conclude our module, let's talk about prompt debugging. When a one-shot prompt fails on complex logic, developers often start tweaking hyperparameters like temperature, top P, or system messages. But in reality, parameter tuning rarely fixes broken logic. The single best way to debug a failing prompt is to perform a manual execution test. As our summary points detail, humans possess a strong cognitive bias. When we write a prompt example, our brains subconsciously fill in logical gaps that aren't actually written on the page. We assume the model understands our implicit intent. To debug this, you must read the prompt strictly as written, acting like a literal interpreter with zero outside knowledge. If a step isn't explicitly shown in your one-shot example, assume the model doesn't know it exists. Let's walk through our debugging example step by step. Suppose you have a prompt for calculating averages that keeps giving wrong answers. By manually stepping through your one-shot example line by line, you realize the example added numbers together and immediately outputted the final average, silently skipping the explicit division step. The model was guessing the division step. Once you update the example to explicitly show sum equals 10, count equals 2, divide 10 divided by 2 is equal to 5, the logical gap is closed, and the prompt succeeds.
Excellent. You've completed part 4 of our one-shot prompting interview series. In our next and final video of this series, we will explore advanced industry use cases, focusing on how enterprise companies implement one-shot logic in massive production pipelines. If you found this video helpful, please like, share, subscribe to SHR Trinity, and press the notification bell so you never miss our upcoming AI interview preparation videos. Thank you for watching. See you in the next video.